All right, in this video, we're going to look at different ways of describing all the inputs and all the outputs of this particular function. So here we've got a graph of a function that has this weird shape that looks, it's like a bent line. Okay? So the domain of the function is all the possible x values that can go in there. Well, if we look at right above the dot on the left, that matches up with negative 4 on the x-axis. So negative 4 is the smallest x coordinate that we have. After that, we have negative 3, negative 2, negative 1, 0. So we have all these x coordinates. There's 2, 2.1, and so on, and we keep going up the line. And the highest y coordinate we have is 6. So the domain is basically all the real numbers that go from negative 4 to 6. So there's a couple different ways we can write it. The first way that we can write domain and range is in set notation up here. Okay, so we're going to start by writing the domain. So in set notation, this is the one that kind of like has the curly brackets. So we're going to say the domain is the x values such that, so now that's such that line there says now we're about to explain which x values exactly we can be. So we're going to say x can be any real number as long as that x is greater than, so alligator's mouth is going towards the x, so it's bigger, greater than or equal to negative 4, and less than or equal to 6. Okay, so this little thing here, really, when you read it out, means such that. So we are defining, we're explaining all the values that x can be. So x can be anything such that x is any real number. And notice the way I've written this statement. I've put the smallest, starting to lose it here, talking to myself. Okay, so negative 4 is the sort of smallest x value. 6 is the largest x value. And this, the fact that we put x in the middle of the two means that, you know, the alligator mouths or the inequality signs kind of go open towards the right, means the things on the right are always bigger. So it's just a way of saying that kind of like x is between that smallest and that largest value. Okay? Now the range, let's actually skip over here and talk about how we would do the domain in set notation. Set notation is a little bit different. It's a little bit easier in some cases. It uses basically like a much cleaner notation. So if we want to say the domain is all the values from negative 4 to 6, we just simply go 4 to 6. Because we can equal 4, we put a hard bracket there, which means that 4 is included in the set of numbers that x can be, and 6 is included in the set of numbers that x can be. So that domain says x can be any number from 4 to 6, including those n numbers. Okay, so that's how we'd write it in set notation. All right, for the range, I'm just going to erase what I got here, and let's look at the range. We have to switch our thinking now to the y-axis. So if we take a look at the highest y value, it's positive 1. Okay, so on the y-axis, this n dot here is the highest one that we have. It has a y coordinate of 1. And all of these dots down here, they all have y coordinates of negative 3. Okay, so that's negative 3 there on the x-axis. So all of these y values are between negative 3 and 1. So let's go ahead and write how that would be in set notation. Okay, so this time we're talking about y values. So y values are any real number as long as those numbers are negative 3 to the smallest is the smallest number, and 1 is the largest number, and y is in between them. Okay? In terms of range, we want to say we're between, and we always kind of go small to large when we're writing the numbers. -3 is the smallest, and we're going to include that we can equal that number, and +1 is the largest. So that's set and interval notation for domain and range of this particular function. All right, in the second example, we're going to look at what happens when the graph keeps going. So here, there's a little arrow on the graph to show that we keep going down and we keep going to the left. It looks like it's only going down, but it's also going to the left. All right, so the domain, well, the biggest number, since the graph starts here on the right at this dot, the domain is there at 6, is the highest x value. And then all the x values kind of keep going to the left. And even though they kind of go off the chart, they keep going all the way to the left. So basically, it's kind of like -infinity is way down there as the smallest x value. So for interval notation, we can say the smallest x value down here is -infinity. Now we do a round bracket because -infinity, we can never actually equal it because it just keeps moving to the left. It just keeps receding off in the distance. So a round brackets means that you can just keep going towards that number. So round bracket, -infinity, all the way up to 6. And since 6 has a closed circle and we're up to there, we put a hard bracket, it's called, or a square bracket saying 6 is included. All right. We are going to then also look at how to do that in set notation. In set notation, we start off the same way. So the part I'm about to write in blue is pretty much the same for every domain. X such that x is any real number. I'm just going to leave a blank. So that part is pretty much always in set notation this year for the domains that we're describing. We're just going to change the part that is specific for the graph. So here we're looking at x values that are less than or equal to 6. Okay? So we're just going to go less than or equal to 6. We don't have to put greater than -infinity because you're always greater than -infinity because that's the most negative number that keeps receding off in the negative distance. Okay? So we would just write that for our domain. For the range, okay, if I just erase all this, we see that the highest y value that we have is up here at 2, and the graph goes all the way down to -infinity. So we can say the range, again, we have to go from sort of low to high or from negative to positive. So the range is, can't touch -infinity, but we can get close close as we want to it if we keep trying, all the way up to 2. Okay, those are all the y values. In terms of the range, y is such that y is any real number. Now let's give in green here, I'm going to write the specific condition for this one, where we're talking all the values that are less than or equal to 2. So y is less than or equal to 2. All right, so that's basically, hopefully, a review of 2 different ways of writing domain and range. Numbers or things that look like this in math are called intervals. And these brackets here are called set brackets. So make sure that you remember which one is which. And in the next video, we're going to look at what the new shape that we're going to be dealing with is. Bye.